Okay, I have created a sample program that is just going to take the input from our green push button, and whenever the green push button is pressed, this rung will get logical continuity, and in doing so, this add function will be initiated. And this add function, what it's going to do is it's just going to add source A, which is whatever's in our integer register, which currently now is 0. This is not a downloaded program. And it's going to add 2 to that quantity, and then it's going to store it right back in N70. So let's see how this behaves. I am going to run this on an emulator. So I will have to be doing this through input tables. And so now I'm running in an emulation software. And I'm going to call up the input table here, and I'm going to initiate what would be a button press. And typically when we press the button, that is true for a significant number of scans before we actually let go of the button. Even though to us it appears like one action, it's actually going to, this line of code here is going to be initiated multiple times, and we're going to see that that's going to be a problem. So I'm going to go to 1 here, and then I'll double click that back to 0. So that's like pressing it and releasing it. The problem here is that every time this rung has a true or rung continuity, it will add 2 to that result. So if 500 scans goes by, it's going to add 2 to N70 and put it back in N70 however many scans goes by. So it looks like we had about 53 scans go by. That's why it's 106. So we need to learn about a new instruction that is going to alleviate this issue, and it's called a one-shot. So I'm going to go ahead and go offline here. And I'm going to add a rung. I'm going to go ahead and put it before here because it makes sense. And I'm going to move this instruction up there. And then I am going to add something called a one-shot rising, OSR. And what the one-shot rising does is it traps when this goes from a false to a true transition, and the output bit here is only going to be true for one scan. Then you'll have to physically remove your finger from the button and press the button back down to get another one-shot rising. And here we just need to assign it a couple bits. One is a storage bit that just remembers what the value was the last scan. So I'm going to use our binary B3, and I'm going to go to the next word so I know I'm not interfering with any of our binary bits. In fact, I'm going to go to the third word, or bit, or word 2. They start at 0, then 1, then 2, and put a look at the first bit there, and I won't give that any particular name. And then here I'm going to go to B3, and I'm going to go to word 1 and use that same bit. Now here I'm actually going to give this a name, and I'm just going to call it a one-shot. And then down here, I'm going to use that one-shot here in this instruction. So if I press down on the, in this case, green push button, this rung will go from false to true, and that will trigger this output bit to come on for one scan. So the very next rung after that, this will be true, and we will add 2 to whatever is in N70. And as long as I'm holding the button down, this every other scan, the remaining scans, this will be false because it's looking for a one-shot rising, or rising meaning from false to true. So we'll go ahead and download this. And I'm going to change this to run. Okay, so if you notice, it's the one shot is false. It's looking for a rising or a false to true transition. So I'm going to go here to my input table again, because again I'm running on the emulation software at home. I'm not actually downloading to a PLC. And I'm going to change this to a 1. Now you might have seen it just very quickly blipped here and then went away. But even though this is still true, much like us holding the button down, I only added 2 to the contents of N70 and stored the contents back into the same register one time, because it only rose from false to true one time. So I'm going to change this back to a 0, and that emulated that I let go of the push button. And if you notice, nothing here happened. Now I'm going to change it back to a 1 again, much like pushing the push button again. And if you notice, it added 2 to the result, and now we have a 4 in there, and it did it only one time because again it only rose from a false to a true one time during that interval. And so this is how this one shot is very, very commonly used with math functions, so we don't actually add too many add functions, more than we actually want. Now, there is a one-shot falling, which is the polar opposite of one-shot rising. It's waiting for the rung to go from true to a false. So let's look at that. So all I'm going to do is change this to a one-shot falling, or F. And so it's going to look for me to release the push button for this one shot to actually happen here. So I'm going to download this. And go back to my run. Okay. So whenever you download, it didn't retain the value of the register, so we went back to 0 there. Okay, so now I am going to emulate that I push the button, and nothing's actually going to happen with our add function here. So I'm going to go ahead and push the button. So you notice I have went from a false to a true, but that's not the definition of a fall. A fall is from a true to a false. So my one shot did not actually invoke our adding function here. So now when I change this back to a 0, then you notice that I added 2 into the N70 register. I'll do that one more time. I'll push the button, or emulate us pushing the button. So you see that I have a logical continuity here, so meaning I have rung continuity, but this did not initiate or fire on my one shot because it is on the fall that it will do that. So that's why we still have a 2 down here in N70. So if I come here and change that to a 0, then I should have a 4 in my N70 because it did the add function one time. So that is one-shot rising and one-shot falling used with a math function. I hope that helps, and we'll see you in the next video.